In this video, we will see how to carry out a k-nearest neighbor analysis for a categorical variable in JMP. The dataset we'll use is Universal Bank. This is a dataset of 5,000 observations, and it has a bunch of features on age, experience, income, zip code, family, and so forth. Our outcome of interest is whether we can convert these individuals into a personal loan acceptor. So this is our target variable, and we want to see what features may drive somebody to accept a personal loan. And we want to then be able to classify a new applicant based on the optimal K that we get, as either will they respond by getting a personal loan, or will they not get a personal loan. So let's import this data set. Again, we have 5,000 observations. One thing to note is that because a personal loan is a 0-1, it gets imported as a numerical variable, but it is a categorical variable. So we can make that quick change in JMP by going to personal loan, right-clicking, and then changing it to nominal. And now, before we get into k-nearest neighbor or partitioning our data, let's understand how partitioning needs to work. So for that, we just want to look at the distribution of our variable of interest. We go to Analyze, we click on Distribution, we move our personal loan to Y and click OK. And we see that only 10% of our observations were loan acceptors. As we have discussed before, to do a k-nearest neighbor algorithm, we need to split our data into training, validation, and test sets. Now, if we randomly partition our data into validation and test, it may be the case that we may not actually have any loan acceptors in our validation or a test set. That will effectively render those sets as useless, and we cannot build our model with that. So what we need to do is a stratified random sampling, where we'll make sure that our loan acceptors maintain the same percentage between our training set, our validation set, and our test set. So let's see how we do a stratified random sampling in JMP. We go to Analyze, Predictive Modeling, and then click on Make Validation Column. So here, it wants to know what variable will we stratify our sampling on. We want to stratify on personal loan. We click OK. Next, we want to specify what percentage of our data will be set aside as training, validation, and test. So let's go with the convention and do 50% of our data as training, 30% of our data as validation, and then 20% of our data in test. Now, sometimes in k-nearest neighbor algorithms, they might have a larger data set as validation in some studies, but I think we'll stick with this convention because this is what we can do with other algorithms also. 50% training, 30% validation, and 2% or 20% test. And then for making our results replicable at a later date, let's just set the seed, and then let's just set the seed as 3, 4, 5, 6, and click Go. So now we have created a column which says training, validation, and test, and these columns are now based on a stratified random sample. So in our test set, we will have 10% of our observations belong to class 1. We'll have the same in training, and we'll have the same in validation, or 9%. So now let's see how we will use these to construct our k-nearest neighbor algorithm. So we go to Analyze again. We can go to Predictive Modeling, and then we could either go to this dialog, or we could go to Partition and choose k-nearest neighbor as our algorithm. Let's keep the tree or nearest neighbors as 20, so it'll check up to 20 neighbors. We move our personal loan as our Y response. I'm going to move everything else except for zip code and age and ID as our X variable. So we'll select all these, and then we unselect our zip code and personal loan. We move these to X, and then we'll move validation to the validation column. So what we're telling JMP is to do a k-nearest neighbor algorithm, start with one neighbor and go all the way up to 20 neighbors, and then tell us the results of classifying a record and validation set based on 20 nearest neighbors. We click OK. So now we see that even though for training set the best k chosen was 1, we will look at what was the best k for our validation set. So when we had k equals 1, our misclassification rate was 0.044. When our k was 2, our classification rate was 0.05. Then we can see that based on this asterisk, when our k equals 5, our classification rate or misclassification rate is the lowest in the validation set, 0.0406. But this does not tell us what we can expect our model to perform in real life. For that, we look at what our misclassification rate will be on our test set based on our k of 5. So 0.05. This is what we can expect to be in real life if we were to deploy a model to new data. And we can see this here even with this plot. The misclassification rate in our validation set, which is the dark line, gets minimized at k equals 5. So then what we get here is the confusion matrix based on k equals 5. So if you look at the validation set and we have k equals 5, we incorrectly identified 4 observations as belonging to class 1 when they were actually class 0. And then we misclassified 57 observations to belong to class 0 when they actually were lone acceptors. How do we want to score new data with this? Once we're satisfied with our algorithm and a choice of k, we can go to personal loan and this red arrow, click here, and we say save prediction formula. It'll ask us how many k's we want to choose. The default k is the k that minimized our misclassification in the validation set, and which is k equals 5. We click OK. Now let's go to our data table. We see that we now have a new column here, which is essentially looking at the nearest 5 neighbors and then classifying a record to belong to the majority class of its nearest 5 neighbors. For example, here we have whatever the 5 closest neighbors were to this row. The majority of classes in those 5 records would have been 0, and this observation then gets classified belonging to class 0. Now, how do we get this idea of nearest neighbors? We can actually save some results to see who is the closest neighbor to each observation. In fact, we go to this top triangle, we click on Save Near Neighbor Rows. So once we do this, again, this is irrelevant for our analysis, but this is kind of helping us to show what was going on in the background. So what we get is the first closest neighbor to row 1, and that is row 3436. Then the second closest neighbor to row 1 is row 301. The third closest neighbor is 2158, and then and so forth. So if our k is 5, what JMP will do is it will look at the predominant class among observation 3436, 301, 2158, 559, and then 37397. These are these row numbers. Then look at the majority of class in these 5, and that's what then was the classification for this record. We can also see how far apart are each of these. Now notice that we didn't have to standardize our observations because JMP by default will standardize all of these variables to be on a standard normal distribution with mean 0 and standard deviation 1. So JMP does that step for us already. If you want to see the distance between 1 and its nearest neighbors, we go here. We can click on Save Near Neighbor Distances, and if you go back to the data table, now we will see actually the distance between our row 1 and it's the first closest neighbor, which we said was 3436, was in Euclidean terms 0.9736. And then the second neighbor, the distance was this, and we see that this will be increasing. So here we get a snapshot of not just what was the prediction of our record based on the optimal K, but also tells us how many. It actually tells us every single neighbor based on the distance of this observation, and also the distances between these neighbors. But for prediction purposes, what we're interested in is just this column, which is coming from the 5 nearest. So if you had a new observation, we could simply type in our outcomes of interest. We could say that this person's age, let's say, is 36. This person has been on the job for 10 years. Their income is, let's say, 45. Zip code we can ignore. Their family size is just 2. Their average credit card is 1. Their education level is 2. And then the mortgage payment, let's say, is 90. And we do not have the personal loan. And then they do not have a securities account. They do have a CD account. And let's say they are an online customer and they do not have a credit card. So based on these, we will get a prediction. And the prediction will be that this individual, based on 5 nearest neighbors, will be classified as a class 0. So we could, if we had more data, we could just copy and paste the data here, and we will get prediction for each of those variables.